Hi everyone, Lee from ESU here, and in this video we're going to continue where we left off from our LokProgrammer setup video, where we loaded a sound file into this Rio Grande tunnel motor here, and we showed you how to get your programmer set up, get a sound file written to your very first decoder. Now of course there's a little bit more we have to do to get it fully set up the way we like. Chances are the lights are not going to match perfectly to the default function mapping and function output settings that are in the sound file. So you have to go in and make a little bit of adjustment. And don't worry, this is totally normal. All of our sound files are going to come out of the box with default mapping that's likely not going to match the way your locomotive is wired. So you might see some odd things, like your number boards are going to flash when you blow the horn, or your ditch lights flash alternately with your nose light in this case. That's how mine works. That's not going to work. So we have to go in and make some adjustments. And it's very easy to make these adjustments. So don't be alarmed when this happens to you out of the box. And one thing we want to make sure that you understand is that physical outputs are where the lights are actually wired to. And what we're going to do then is configure the light to do the effect we want. And we'll show you how to do all that using the LokProgrammer software and show you how to further get this all set up. Stay tuned. All right, so now you'll notice that our Rio Grande tunnel motor happens to be an Athearn RTR model. They're just in the Athearn line, they've dropped the RTR, but you'll also see this board in Genesis models as well. And just kind of an explanation of how this board relates to ESU decoders. We'll take a quick look at it here. You'll see the 21-pin dummy socket here in the middle. This would come off and your ESU decoder would plug on in its place there. Same orientation with this black header pointing up. And then you'll notice a bunch of wires that are connected to this. The outer pins here on the edges are going to be going to your track power. So this goes down to the trucks. There's wires that'll go down to the left and right rails on the front truck here and on the rear truck here. These do not get lights connected. If you hook a light there, bad things are going to happen. So make sure these only go to where the trucks are wired. And then the middle two are going to be for your headlight, and the rear ones here in the middle are for the rear headlight. And then along the bottom here, you're going to see F3, F4, F5. And up top here, you'll see F6. Over here, you'll see an F8 and then an F7. In the ESU world, that translates to aux1, aux2, aux3, aux4, and then F7 is aux5, and F8 is aux6. And so if you have wires going to these pads, you'll be able to then understand how the lights are wired when you hook up your ESU decoder and which lights activate when you turn on certain function keys. So for instance, if you have a light going here to the F3 pad, you'll know that that light is controlled by our aux1 in the decoder. And hopefully that will kind of make a little bit more sense when you get going here. These other contacts here are for the motor, motor minus, motor plus, and then you have speaker, plus and minus here. And for ESU decoders, there's no worry about polarity unless you're using more than one speaker. If you do use an 8-ohm speaker or two 8-ohm speakers, you can wire them in parallel. If you're using two 4-ohm speakers, you would want to wire them in series, and then polarity does matter. But they are labeled here S plus and S minus. If you're just using a single speaker, either wire going to the speaker, it doesn't matter. So that's just a quick little breakdown of this board. I know the markings are relatively small, but that's kind of how that works. So now let's get on to the programming. All right, so of course once you've gotten your sound file written to the locomotive, you're going to want to go to the driver's cab and then see how the lights actually do work in yours. And so you would just click on driver's cab here in the upper left corner, hit go, and we're just going to turn on the lights. So we have a headlight, you should see that come on. We're going to hit 5 and 6 because these are typically going to be lights on an ESU decoder out of the box. So let's see what 5 does. So 5 actually is working the beacon up here on the roof, which is very difficult to see, but it is on and it is doing the beacon effect. And then function 6 here is going to actually turn on our nose light and our ditch lights. And what you'll notice when that happens is if I hit the horn, they will flash alternately like ditch lights would alternately flash. And so this is one of those things that you might actually experience on your locomotive. Now, you might have number boards that flash or something else that flashes like this. That's not quite correct. But this gives you an example of what would happen. This locomotive doesn't happen to have number boards that light up, so the operation is a little different, but if you do get one that does that, don't be afraid. We can get it figured out and we can get it straightened out for you. So this will help us also determine what lights are wired to which outputs. When you were installing the decoder, if you didn't take notes or you weren't able to trace the wires back to specific lights, that's okay, no big deal there. We can still figure it out using the function mapping and how the lights operate off of different function keys. And so that's what I wanted to point out to you here, that we see that function 5 is operating the rooftop beacon and 6 is operating the nose Mars and the ditch lights. Now there's one possibility that the nose Mars and the ditch lights could actually be wired together, making them come on together. However, that's not the case, and we can find out how that works here shortly. So what I'm going to show you is, we'll go ahead and stop this. We're going to go in here to decoder, and we're going to go down to function mapping. And in function mapping, you're going to see that on function 6, we have 2 outputs mapped to the same function. So the first thing that you're going to want to do is separate those onto separate functions to prove if they're wired together or not. And what we're going to do is just temporarily use function 3 as our test function. We're going to get rid of the coupler by just dropping this down and unchecking it. And we're going to drop down physical outputs. And we're just going to map one of the 2 of them, and I'm going to use aux2 in this case, to function 3. And then we're going to remove function 2 from F6. So now we see aux2, aux3, and aux1 on 3 separate functions. And what that's going to allow us to do is hit those 3 separate functions, and it'll determine what lights turn on. Now one last part of this we have to do is, we actually also have to remove grade crossing logic so that we don't have anything flashing. We can then write the decoder data, and there's 2 ways to do that. So we go up here to the little red arrow pointing to the right, or we can go to Programmer and write decoder data. You can also use the keyboard shortcut Control-W. So we're going to do that. For now, we're going to uncheck this overwrite defaults with current values, and we're going to hit next. And it's going to write our changes to the decoder relatively quickly. And now we can go back to the driver's cab. We can actually now activate function 3, and we can see that only our nose light turned on. And function 6, now only our ditch lights turn on, and they turn on separately. So I can now turn off the nose. So now we see that the lights now are known to be wired separately. We also now know what light is wired to which output, based on how we just remapped it. Now we have that knowledge that function 5 is going to be aux3, controlling the beacon, and function 6 was controlling both the ditch light and the Mars light, the nose Mars light, but now we know that aux1 controls the ditch lights, because it turned on with function 6, and the nose light is being controlled by aux2. So now that you're armed with that wealth of information, we can go into function outputs and configure everything the way we want. So now that we know that aux1 is controlling the ditch lights, and in this case the 2 ditch lights are wired together so they don't flash, they don't alternately flash. However, if you wanted them to alternately flash, you could go in and move them to another output on the factory board, maybe to the F6 pad, but for now we're not going to get into that too much. What we want to do, since these are non-flashing, is we're just going to make them a dimmable headlight with fade. And then we're going to change this to just being ditch lights, because both ditch lights work together. Now one thing to note, these names up here are only for you as the human to understand what the output is controlling. This does not get written to the decoder, and it has no bearing on what actually happens. If your ditch lights happen to have a different name, it wouldn't matter. You could call them Joe Smith and it wouldn't make a difference to how they actually turn on and off. So this name here is just for you to understand what's going on. And then aux2, since we know that that's the nose light, we're going to call it the nose light. And in a Rio Grande locomotive, it would be a Mars. So I'm going to call it nose Mars. And we're going to actually come down here to the output effect and make it a Mars light. Now you'll also see some other things in here. Phase shift is set to 32 and grade crossing is enabled. In this case, we really don't want that. So phase shift is for 2 opposite alternating outputs, such as flashing ditch lights, to alternate back and forth. We don't really need that for a Mars light, so we can put this back to 0. We also don't need the grade crossing logic, so we're going to turn that off. And so now we have the nose Mars light set up on aux2 the way we want, and we have our beacon on aux3. Now it's already set up for a rotary beacon effect, but we don't want it necessarily to be called emergency light, so we're going to change the name just to what it is, rotary beacon. So now we can keep track of it. You'll also see in here that aux4 and aux5 are highlighted in black, but they're not actually wired, they're not actually being used in this locomotive. So you can either ignore them, or you can delete them and put them back to just a dimmable headlight if you'd like, or you can just leave them alone. They will not affect the operation if the lights aren't wired up. So now we're going to go back over to function mapping, and we're going to try to set this up. What you're going to see in here now is we have several options to set this up. We can choose what function keys we now want to control these outputs. And this is one of the things that I want to make sure that you understand is you don't have to put function 3 on aux3 and function 6 on aux6. These aux outputs are just simply physical outputs where lights are wired. It doesn't have any bearing on what function key turns the light on and off. So this is just one of the steps, is just figuring out what the light does, and then the next step is figuring out what function key on your DCC system you want the light to turn on and off with. And so in this case, we have some options. And what we're going to do first is we're going to actually move the aux3 output for the beacon to function 3. Now that just happens to be coincidence. You don't have to do that. 3 and 3 don't necessarily correlate. And then we're going to move F5 to being the ditch lights, which was going to be unchecking 3, and then ditch lights were on 1, and then 6 we want the nose light. So we're going to uncheck ditch lights and put the nose Mars there. And so now we have our 3 functions that can control the 3 effects. So we'll write that to the decoder, and we can test it. This is just one of many possible configuration scenarios, and I'll run through a few of them here so you can kind of decide what you'd like for your setup. And there's more even than what I'll show you. So we're going to turn on our headlight. We're going to turn on 5, which is going to turn on our ditch lights. And then 6 now does the Mars light effect. And we also have the beacon up here on 3. And it's very hard to see in the video, but the beacon is flashing. So that's one scenario for how you set it up. It takes 4 function keys to do this way. Now you might say that's too many function keys. Okay, fine. So now we can turn these off and try some other options. You can combine things if you'd like. You can put the rotary beacon on maybe with the prime mover, having it turn on with the prime mover, which kind of would make sense that the rotary beacon would only activate when the prime mover sound is on. So in order to do that, you can just come in here and put aux3 in here on the F8 line. And now when you press F8, the rotary beacon will turn on. That's your choice there. If you'd rather have it separately controlled, of course, you'd want it on a function key that can separately control it. So for now, we're going to not do that. One of the things I wanted to point out, kind of maybe a little bit more advanced, is we can actually combine things, but also have a little bit of a delay. And this is where things get a lot more fun, is combining lights and then having a delay. And so one of the things I like to do is combine my ditch lights up here with my headlight and put in a little bit of delay. So the headlight will turn on, and then shortly after, the ditch lights will turn on. So one thing we can do is add another line in here to do some fun things. By adding another line, simply come down and drag down all of the cells and then use the down arrow, and then it's going to move everything down. We're going to actually move these 2 down as well. Didn't have quite enough screen spot to do that, so we'll just do that. And so now we have a new line here under forward F0. What we can then do is put in another condition for forward F0 with maybe F12, which is currently the dimmer function. We can say off. Now why would we want to do that? Well, now if I put the ditch lights here, when I dim the headlight, this is going to automatically turn the ditch lights off, which is a very prototypical effect. Now maybe we also want to have our nose Mars light turn on with F0. So again, we can come in here, Let's create another line. We don't have quite enough screen space, so let's just do it in a couple of chunks. There we go. Now let's create another line. So we can go forward, F0. And this time we will not do the F12. We're going to put in the Mars light. So now what's going to happen is, actually we are going to do this. We're going to do an F12, but we're going to leave it on. And so now the Mars light will stay on. Now there's one other aspect to this that we'll show you. But what now is going to happen is we don't actually need to have any of this in here. We can move the rotary beacon back to another function key, typically F5. So we'll put the rotary beacon back on 5. And we'll get rid of the nose Mars light here on 6. These are kind of the fun things that you can experiment with on your locomotive as you're setting it up. So now let's see what's going to happen here. Actually, now that we have F12 in here, that's going to require F12 to be on for the nose Mars light. So maybe we actually don't want to do that. Let's just ignore for now. Now this does look like it's a repeat, but there's a reason for it. So let's just rewrite this. You kind of have to think about the conditions that are going to activate different sounds and different lights down the line. So it takes a little bit of trial and error to get there. But we're going to do now the headlight. You can see that everything turns on. When I just hit one key now, everything just turns on, which is really kind of nice. Now if I hit 12, you'll see that the ditch lights turn off. The headlight and the Mars light will stay on. Now the headlight, of course, went dim. So we're almost there. There's one other little thing we want to do, and that is to set up the nose Mars light to also dim when we hit F12 for the dimmer. And what we can do there is we can set up a forward F0, F12 on as our aux2, our aux2.2. And I'm going to explain what aux2.2 does. It's an alternate lighting effect that you can put on the same output. And that's going to be really fun to play with. So now we have a forward F0, not F12. Again, to get the not, we would just turn the function off. And now we're going to put our ditch lights in here, our aux1 and our aux2. We're going to put them both in here. And you can, of course, combine the lights. And we're going to leave our beacon here on 3. Now, what we have to do really quickly is go back to function outputs for our aux2.2. This is also the nose Mars, but what we can do is put in nose Mars dim. And now we can put dimmer, LED mode, put the fade back on there. And so now what's going to happen is when we hit F12, the nose Mars light is going to dim. And what these aux1.1 and aux2.2, what that simply means is that you can now have 2 different lighting effects on one output. It's a very unique feature to ESU decoders. And on the first 4 outputs, you can choose to do these kind of fun effects. And so now what will happen is when we turn on F0, the Mars light will come on, but when we hit F12, the Mars light will dim. So let's write that to the decoder and show you what happens. It's really fun to play with these kind of things because you can get some really neat lighting effects out of it and mostly control everything on one key. So now 0 turned on all the lights as we expected, and 12 is going to pull the ditch lights, and the Mars light now just goes dim, just like the headlight. So that's kind of a fun little effect, and if I put the ditch lights back on, the Mars light effect continues to operate. Now one thing that we might want to do is have the ditch lights delay a little bit. So I want to talk really quickly about function outputs and the function delay. So on function outputs page, for each lighting effect, you're going to see a power on delay and a power off delay. And what we can do is play with this a little bit to get a slight delay out of the lights turning on. Just like the engineer would be rotating a switch in the cab, we can put a slight delay in here. And I find that a 1 or a 2 generally works pretty good for this. We're going to leave it at 1. And this is a neat effect. And so now what we can do is write this to the decoder. And we'll show you that when I hit F0, the ditch lights will delay just slightly. And you can choose how much delay you want, of course. But now when I hit 0, everything comes on, but the ditch lights are just a little bit behind everything else. And so that can create a nice little effect. And of course, you can always do that on a power off delay as well. You can have a little delay for them turning off, which is kind of also a fun effect. Because like we see there, the Mars light turned off right away. So maybe we want a little delay on the Mars light turning off. So we could put a little power off delay on the Mars light, and now it will delay turning off. But before we write that to the decoder, I want to touch on function settings really fast. By default, in our sound files, the frequency for the blinking effects is CV112, and it sets to 39. That's a relatively slow flash rate. And I like to lower this number down to about 24. A number of 20 to 24 is generally pretty good. And what that does is it makes it a little bit faster. It slows, or not slows it, it speeds it up. So it makes it a little bit quicker, and you get a little bit better of effect out of it. So let's show you how that looks here. We'll write that to the decoder. And again, you can write to these decoders thousands of times, so don't worry about that. And we'll go ahead and get that. And now we can see what that looks like. When we turn on our lights, you'll see the Mars light now is flashing quite a bit faster. Now it also will affect other lighting effects as well, such as the beacon. So now the rotary beacon is also flashing much faster than it did before. They're also now flashing at relatively the same rate. And so that might look a little strange that the beacon and the Mars light are flashing in sync with each other. So maybe you don't want that. So now what we can do is play a little bit with our phase shift back here on function outputs. And phase shift here for aux2, for the nose Mars on aux2 1, we're going to set this a little bit different. Actually, we're going to use, we're going to do them both. We're going to do aux2 and we're going to do aux3. So aux2, I'm going to set to a phase shift, you see phase shift down here, a value of 21. And then our rotary beacon is going to be set for 6. And that's quite an offset. We'll write that to the decoder. It's going to be a little bit difficult to see the beacon on camera, but now the beacon and the Mars light will not flash at the same time. And I can try to get a little bit darker above it here so you can see it. But now you'll see the Mars light and the beacon are just a little bit out of sync with each other. And that makes for a much nicer effect. So there's just a lot of different ways you can do this. That's just a couple of examples. Of course, if you wanted to tie lights together in different ways, you can, like I said, tie the beacon in with function 8, have it turn on with the prime mover, have function 5 turn on the ditch lights, have function 6 turn on the ditch lights, maybe 5 turns on the nose light. You could have 5 do the beacon, 6 does the ditch lights, and the nose light is tied up here with the front headlight. There's all kinds of fun things you can do, and that's how it all works. Now you can also add things here at the bottom in blank lines. If we wanted to add something here, instead of dragging all the cells down and doing it that way, you can always add things here at the bottom. That works perfectly fine as well. You can also add items here at the bottom and then use the arrows to move things up that way. It's a lot of clicking, that's why I like to just highlight the cells, but you can do that. You can move things around however you like. Maybe it's better for you to have things a little bit different order, so you can change the order. However it works for you, you can move things around using these arrows. If you want to delete all the contents of a line, you can hit the red X, and that will delete all the contents of a line, and you can start over and reset everything. The one thing that we want to caution you about, and definitely don't press, if you're in North America especially, is this restore default mapping. This will put everything back to the multi-protocol mapping of the European style decoders, and things will get really strange for you. Function 1, instead of activating a bell, will activate the prime mover, and you probably don't want that. So really try to avoid hitting this. Definitely do not hit this. It will not restore it to anything that you've set up or anything like that, or even how the file came originally when you downloaded it. It will not do that. It resets it back to a European built-in function mapping standard. And so things will get messed up. So if you ever get stuck, of course, and nothing's working, you can always do a CV 8 to 8, or you can come in here to the read-write CVs, do CV 8 to 8 here on the read-write CVs page and reset everything. You can always close the software and don't save it, and then reopen it, rewrite the data, and start over that way as well. Since you have a programmer, it makes it easy to do that. But definitely don't get too discouraged with what you see out of the box, and make sure that you just kind of have a little fun with this and set the lights up kind of the way you'd like. But again, one thing just to point out again is that physical outputs are going to be the output on the decoder where the light is physically wired to, and then you can come in here and choose what that light is going to do on your locomotive, whether it's just going to be simply on and off, if it's going to be a beacon, a Mars light, ditch lights, whatever it happens to be. That's how that's going to work. And I'll touch on ditch lights. If you do have opposite flashing ditch lights, of course you'll want to use ditch light type 1, and one of them has to have phase shift of 0 and the other one has to have phase shift of 32, and that's what makes them flash alternately. Likewise, for both outputs, grade crossing needs to be checked, as you can see here. That way, when you map grade crossing to function 2, which is typically how we would do it, when you blow the horn, now it triggers the grade crossing logic to make the ditch lights alternately flash. So if you happen to have a locomotive that has that set up and they're wired separately to separate outputs, that's how that would work. Note that if the two lights are not wired, the two ditch light lights are not wired to separate outputs, they're going to flash together. And the only way to correct that is to separate them on the motherboard or on your decoder to separate outputs. There's nothing you can do in software to fix that one. So just be aware of that. So that's pretty much going to wrap this up. Hopefully it made sense to you, and you got a lot out of this one. All right, we thank you for watching this one on getting your locomotive set up with the LokProgrammer and the LokProgrammer software. We hope you enjoyed it. Hope you got a lot out of it. You're getting your LokProgrammer getting going and everything, and all the lights, fun lights that you can set up here on your locomotive. Now, of course, again, don't be too afraid if your locomotive comes out of the box, you put in a decoder, you write our sound file to it, and the lights aren't quite right. That's what this is for, is to go in through and show you how to get everything set up. But of course, if you didn't get everything you wanted out of this video, and maybe we missed something that you want to discuss with us, send us an email at support@loksound.com. We're always happy to help you. And visit our website at loksound.com, where you can find more information on the LokProgrammer, the LokProgrammer software, all of our different decoders, LokSound, LokPilot, all the great stuff that we have in the world of ESU. And we thank you for watching. Have a great one and enjoy running your trains with ESU.